So I'm going to give a very broad overview of what panel optimization means for electrification. And before I go into my slides, I will mention that I've been sort of monitoring some of the chats, and there's a lot of great resources. And what I've done in this presentation is pulled information from information that's already available through the 9-county area. A lot of the folks that are on this call have developed resources. So my presentation essentially is a meta presentation of information that's already out there. I'm just trying to compile that in one place. So with that, I'll move to the next slide. I've tried to give credit and links to resources where I pull those from, but if anything is missing, I can certainly add those offline or during the Q&A. So just about TRC, just a short plug here that we are an energy efficiency and environmental consulting firm. We've been doing a lot of work around building and transportation electrification. And one of the biggest challenges, as I'm kind of interesting to hear, all of the counties' pain points are essentially the areas that we've been trying to work on, because those are the challenges where anytime you have something new and it requires both a behavioral or customer acceptance and a technology solution, there is a challenge on how do you get that to scalability. So that's the area that I and my team have been focused on. So with that in mind, just kind of let's go to the next slide, which I want to kind of just maybe take it back to basics. And for some of you, or maybe many of you, this would be repeat of information you already know, but just in the interest of bringing everybody along, what is electrification of homes? So I borrowed this graphic from City of Palo Alto. You're looking at those items numbers 1 through 5. You might be upgrading your heating system, your clothes dryer, your cooktop or oven. You might be upgrading your water heater or vehicle charging at home. And all of those things require consideration of what the electrification options are, and that might have an impact on the electrical panel. So the number one question we all get asked is, do I need to upgrade my panel? The short answer is no, not all homes require panels to be upgraded. In fact, a vast majority may not. The slightly longer answer is there are several options currently available, but this is a case where each home and your unique situation will need to be assessed for feasibility and technical fit. And I'll go into a little bit more around what those might be going forward. So on the next slide, I want to also get to a little bit more about two aspects that often get somewhat commingled. So people talk about panels, people talk about service. Just to kind of set the tone here, service typically refers to the kind of power you're going to get from the utility to your home. In other words, that is essentially the bandwidth of what you can do, because the utility can't provide you more than that. For most newer homes, 200 amps is standard. Older homes may have smaller service, but really that information needs to come from the utility. It's not really easy to get that from any other source. The panel here, if you look at the graphic on the right here, the panel is that little box to the kind of the middle right here. That is the device, or that's the location where the service from the utility is then distributed across your home through multiple circuit breakers. And a lot of times, depending on the age of the home, depending on the age of the panel, you might have a different number of circuits, different number of breakers. You might also have a situation, especially in older homes, where they haven't been very careful in how these things are wired. And so you might have multiple devices on the same circuit, or as was the case in my house, my bedroom lights were wired with my kitchen outlets kind of thing. So oftentimes there is a mismatch in terms of how things are done. So in general, when we talk about panel upgrades, we're really talking about upgrading that panel that is on the customer side. On your house, that's the box that's sitting outside your house. And service is typically, in many cases, the overhead wire that you see coming to your house. In some cases, it might be undergrounded, so you don't actually see it, but it's the service that comes to your house from the utility. So let's go to the next slide. A couple of things also get commingled, so I'm trying to kind of have some separation in those. There is upsizing and then there is upgrading. And many of us have started to use language around this, and this is still evolving. So people might use different languages, but just for the sake of this presentation, when I say upsizing, I mean generally choosing a larger capacity. It might mean going from your 100 amp panel to a 200 amp panel, that kind of thing, or going from a 100 amp service to a 200 amp service. Upgrading usually means choosing something that's better than what you have. And so I've pulled in some of the common reasons why people upsize or upgrade. I've sourced the studies down below, and some of this is my interpretation of those studies. But in general, uh, reasons why people say they want to upsize, and I'm not going to go into whether these reasons are always valid or not, but some of the typical reasons given are you're installing a larger solar system than your existing bus bar, as in the capacity of your panel can accommodate, or you might be including level 2 EV chargers, um, and you might be doing HVAC upgrades or installing one where previously there was none. Upsizing will often include upgrading. Most cases, you might need to upgrade your panel. You might, in some cases, do away with that by adding a secondary panel and so on, but usually upsizing will include upgrading. Some of the reasons why panels may be upgraded but not necessarily upsized is, as I mentioned, there might be space constraints that not all circuit breakers, there is no more space available for adding a new circuit or a circuit breaker. The panel may be unsafe. It might be an older panel, older fuse boxes, and it can no longer is deemed safe to handle the loads. So again, upgrading may not necessarily require upsizing. So just keep that in mind as we go forward with this. And on the next slide, many of you might be familiar with this. Um, so the concept many people have proposed, and Tom is on the call, and Tom's one of the people that's kind of developed this. But the idea is, and when we talk about optimizing panel, what we really mean is stay within the limit of what your panel can provide in terms of the total amperage and power. And there are a number of ways that it can be done. I've copied one example on the right of a 2,000 square foot home that has a 100 amp panel. Generally speaking, this watt diet concept talks about three things. One is you want to use power efficient appliances. So generally, where possible, go with appliances that use less power. 120 volt appliances will use less power in general compared to 240 volts. Again, I'm making generalizations for each of these statements. There might be exceptions. If you have 240 volt appliances, there are options where you can have lower power draws and lower amperage draws from those devices. You can also look at all-in-one devices. So instead of, say, a separate electric range and a combo and an oven, you can get a combo device that uses less power than those two things wired independently. You could have newer devices that are providing hot water for both domestic hot water and space heating needs. And then lastly, I think in all of this, careful planning is needed because you want to make sure that things are circuited correctly, that similar appliances and similar loads are on the same circuit. So in some cases, you might need to move wires, as I had to do on my house, so that all your kitchen outlets are on that kitchen outlet breaker and not distributed across multiple and that kind of thing. But I think this is where conversation with the electrician, the contractor, and the homeowner is necessary. And to the pain points mentioned earlier, this is where I think that knowledge sharing, training, and understanding what resources are available are going to be critical. So some of the other ways that can be done, again, part of the watt diet is circuit sharing. So this is a case where the same circuit has two different loads on it, and either through a smart breaker or another device, you can decide which of those two devices will be working at once or one at a time. You can set priorities for which appliances take precedence over the others. So as an example, in the graphic on the right that I borrowed from the watt diet calculator, you can see that the clothes dryer and the EV charger are on the same circuit, and the range and the cooktop is on the same circuit as the heat pump water heater. The idea being that it's very unlikely that you're going to use both at the same time, and you can set those in a way that they are used at different times, or when you need to use them, there's a order in which something will be given preference over the other. So those are again strategies that will have to be thought through and worked through. Let's go to the next slide. Just building on that last slide, there are options where you can upgrade the panel without having the need to upsize. Uh, Things like smart breakers. These are individual circuit breakers that have smarts built into them so they can manage the load on that particular circuit. Many of them offer connectivity, so you can have remote control through other devices. Um, then there are circuit sharing devices that allow sharing one breaker for multiple devices. So if your breaker itself is not capable or your panel itself is not capable, circuit sharing devices offer you that capability. They are generally installed, quote unquote, downstream of the breaker. And then there is the smart panel, which is all of the breakers are smart, and the panel itself has built-in capability to manage the overall load. In this case, each of the breakers will do its job, but there's also a supervisory function to manage load across all of these. And all of these also offer remote management capabilities. Some of the other options to avoid upsizing, as I mentioned, power efficient appliances. So a little bit more on those 120 volt appliances. So there's a lot of new products in the marketplace, and there's just a major study completed in California that has information on 120 volt heat pump water heaters. These are often also called plug-in because you can plug them into any standard outlet. There's also versions of the 120 volt for space heating, whether they are ductless mini splits or through the wall heat pumps. You do have to make sure that there is a dedicated circuit or work with circuit sharing devices for those. On the EV charging question, there's a misconception, and many of us fall into that kind of false sense of I need a level 2 charger. I have a EV that I charge with just a level 1 charger out of the box, and I've never had problems with using it. The average commute is less than 40 miles a day. Most of our EVs can work just fine with level 1 chargers. But if you do want a level 2 chargers, there are several devices now that offer you abilities to manage the load that those EV chargers put on your system. And there are several devices for that. Some of it is built into the OEMs for the EVs themselves, but there are also other devices that you can add on. And then lastly, I mentioned the combination devices. There are a few devices that are already out in the marketplace, and there's a couple that we've recently completed studies, especially with that water and space heating as a single device. The advantage, apart from other on the electrical side, is many of these also have space benefits. So there's multiple reasons sometimes why we want to do these combo devices. So let's go to the next slide. So I'm just going to take a minute here to talk about why we were talking about panel upsizing or avoiding that, or why do we want panel optimization. Generally, they add, if you don't do it right, if as was the case in my house, and I think many of you have mentioned this on the chat, and in the some of the county reps also mentioned this, is I got sold on adding a new panel. I knew enough not to do that, but upsizing that panel, upsizing the service adds thousands of dollars to the project cost. Oftentimes, the cost of that might exceed the cost of the electrification that you're doing. Upsizing panels will also involve rewiring and recircuiting and so on. You definitely need permits and utility sign-offs. Again, these things are doable, but they add a lot of time and cost. Sometimes, especially on the service side, weeks, if not months. And so that has real implications, not just on our personal finances as a homeowner, renter, But at a broader scale, we are trying to decarbonize our grid. We're trying to decarbonize our homes. Even though we have a lot of resources in California, they are still limited. And if we don't do this right, we can waste billions of dollars, and not to mention goodwill. Every time a panel or a service is upgraded or upsized, rather, without careful consideration, that's money we're taking away from electrifying another building or putting that money towards educating contractors or others. So this is an important need that I think many of the panelists later on will kind of expand on. So with that, I think that is my last slide, I believe. So I'll pause here and I'll pass it on to the next presenter.